Very good morning, everyone. Hope you all are fine and safe in this COVID pandemic. On behalf of A.G. Patil Institute of Technology, Solapur, I, Madhura Kulkarni, welcomes Dr. E. Suresh Babu, Chief Guest for Inauguration and today's speaker, Honorable Shri A.G. Patil Sir, President of Shanti Education Society, Honorable Shri S. A. Patil Sir, Secretary of Shanti Education Society, our Campus Director Dr. M.H. Augule Sir, Principal Dr. S. A. Patil Sir, Vice Principal Dr. V.V. Poddar Sir, Coordinator of the program Dr. R.V. Garekar Sir, Head of all departments, my colleagues and dear participants. I heartily welcome you all for 1 week online induction refresher program on Internet of Things approved and funded by All India Council for Technical Education and the Indian Society for Technical Education, New Delhi. Today, we are starting with the second slot of the program, that is from 7th April to 12th April 2021. We have received an excellent response for the program and we are grateful for the same. In these 6 days, we are going to listen about the different facets of Internet of Things by eminent speakers from academia and corporate world. All these sessions are live on Google Meet. Now, I request coordinator of this program, Dr. R.V. Garekar Sir, to convey the theme. Over to you, sir.
Good morning, all. All the dignitaries on this online platform, coordinator of the FDP and head of the computer science department, Professor S.V. Kulkarni sir, Vice Principal Dr. V.V. Poddar sir, Principal Dr. S.A. Patil sir, Campus Director Dr. M.H. Augule sir, and all the participants present over here, along with the today's guest of honor, Chief Guest of Honor, Professor Dr. Suresh Babu sir. Along with all the participants, I would like to welcome all the participants from the different regions in the country to this online refresher program. It's being a great pleasure to inaugurate today's online refresher program on Internet of Things, sponsored by AICTE IST, with the overwhelming response by you all. Friends, it is a unique role to be all. Just a moment. It's a unique role to we all the technocrats to keep updated ourselves with the recent trends and technologies, with the futuristic vision for the welfare and the development of our society and hence the nation. The program in front of we all is designed and developed with the number of eminent and versatile speakers in the domain, as we can observe in the presentation slide. Different eminent speakers are present over here with us from NITs and IITs and from different regions, from the worldwide locations, for igniting the spirit of research and continuous development amongst we all. So along with that, the whole program of these 6 days, as we can observe over here, can be considered to be necessary and sufficient for emphasizing the attributes of Internet of Things and to ignite a spark of research in the domain. I request all the participants to attend each and every sessions with the continuous and at the maximum attachment possible. We all have to respond to the test and the feedback of every day, as well as we have to appear for the examination at the end of 6 days session, and we all are expected to make this program to be a damn successful for the welfare of society as well as for the welfare of our nation. Thank you.
Now I request our principal, Dr. S.A. Patil sir, to formally inaugurate this program. Over to you, sir.
Good morning to all. Am I audible?
Yes, sir.
Yes, sir.
So first of all, I welcome today's chief guest, Dr. Suresh Babu from National Institute of Technology, Warangal, and all the participants. So this is the second phase of our faculty development program under this IST, and first phase is successfully conducted in the month of March. Now in this April month, we are conducting this one. The purpose of this program is to train all the students in this emerging area, that is Internet of Things, which is a sort of interdisciplinary one. It is equally important for electronics, computer science, as well as even the other mechanical civil engineering also. So I once again welcome all the participants for this program, and in the next 6 days you will be learning a lot about this, and I hope that you will transfer this knowledge to your students. Now, for the information of our chief guest, let me introduce our institute. So this our institute, A.G. Patil Institute of Technology, was established under Shanti Education Society in Solapur in 2008. Our institute is NAAC accredited, and we have got presently 4 branches: mechanical, civil, electronics, telecommunication engineering, and computer engineering. So our almost 9 batches have been passed out, and almost more than 2,000 students are working in the field, and they are contributing themselves in the nation building. So this our Shanti Education Society was established by our chairman, Honorable Chairman Sri A.G. Patil sir, and its day-to-day activities are being run by our Honorable Secretary Sri S.A. Patil sir. Along with this A.G. Patil Institute of Technology, we have got A.G. Patil Polytechnic Institute also in the same campus. We have got around 15 acres sprawling campus, okay, with all the facilities, with in-house canteen, okay, hostels, etc. All the facilities are available, and all our faculties are doing very well. And even for this faculty development program, our own faculties as well as the very renowned faculties from NIT, IITs, okay, they have been invited for this, for the benefit of all the faculties and students. So once again, I welcome all of you. I welcome chief guest, and I hope that all the participants will get a lot of knowledge, okay, out of this. Thank you very much.
Now I request our Vice Principal, Dr. B.B. Poddar sir, to address the audience. Over to you, sir.
Okay, good morning. Am I audible and visible? Please confirm.
Yes,
Yes,
sir.
sir.
Good morning. You are visible.
Good morning. Very good morning to everyone. The dignitaries present for this inaugural function, the chief guest and our course speaker, Dr. Suresh Babu sir, our campus director Chogule sir, our principal sir, all HODs, all faculty members, and all the participant friends. Indeed, it's a great morning for all of us because we are into this second phase of IST and AICT sponsored refresher course on Internet of Things. We completed the first phase very successfully, and we'll be having one more phase because we had many participants who were in the queue. So I requested them to join the third phase. All in all, it was a pleasant experience for all of us in the first phase, and we hope in this phase also it will be more interactive, more participative, and we'll learn a lot of things related to Internet of Things. Now, friends, we all know Internet of Things has become a buzzword in today's era. Everywhere you'll see applications related to Internet of Things. Let us quickly review what are these application areas. As we all know, IoT is the acronym in English for Internet of Things, which is a term that refers to the connection of objects to each other and to human through the internet. And we'll be surprised to see many application areas, practical application areas. We have wearable devices like virtual glasses, fitness bands, GPS tracking beds, which are being used in day-to-day applications. We have health-related applications wherein we have the sensors which are connected to patients, which allows the doctor patient's condition outside the hospital and all real time. This is a big boon healthcare industry, friends, which helps patients in seeking the help from the experts in the medical field by using these wearable sensors. And in the today's pandemic, we have many vital parameters like blood pressure, oximeter, body temperature, and other things are being used by healthcare professionals. I would proudly like to mention one of our alumni has developed this IoT-related application, and which is being used in railway hospital, which is IoT-based device that he has developed. And as we are in traffic monitoring also, IoT is being used to develop smart cities in large cities. Google Maps is very active traffic monitoring exercise. In transportation management also, IoT is being in agriculture. The quality of soil is crucial for good production of crops. IoT is being used assess the soil condition in real time. Information such as soil moisture, level of acidity, the presence of certain nutrients, temperature, and many chemical characteristics help the farmers in controlling the amount of irrigation that is required, and the output of the agriculture can be optimized. It can also help in help the farmers in assessing the presence of diseases as well. And in hospitality industry, friends, it is being used widely to improve the quality of service provided to the customers. Mobile devices are the mobile devices-based IoT applications are developed and to the given to the customers so that they can have efficient room service. As far as electricity is concerned, smart grid and energy-saving applications are being developed, which are based on Internet of Things. In water supply, efficient water supply, IoT is being used. In industries, you must have heard, it has become a buzzword as well. Industry 4.0, people used to talk, now people are talking about Industry 5.0 with the help of IoT, wherein maintenance management and condition-based maintenance, CM, are being done by using AI algorithms and machine learning and deep learning algorithms with the help of IoT-based applications. The maintenance, or what you can say, the productive maintenance based activities are being carried out in industries. Like that, these are the few application areas we are going to see in this 1 week refresher. And I hope the experts feel, mostly who are from NITs, and few are from probably Vietnam, if I'm not wrong. So we have international guidance being done throughout this 1 week FDP. And I hope all the parties will take maximum benefit out of this. And at the end of the session, or at the end of this course, I hope we'll come out with some fruitful IoT-based applications which are relevant for the society and which will be beneficial to the society. So I wish all the best for all the participants. Thank you. Over to you, coordinators.
Thank you, sir. Now, I feel privileged to introduce our today's chief guest, Dr. E. Suresh Babu. Dr. E. Suresh Babu belongs to National Institute of Technology, Warangal. He has obtained the PhD from JNTU, Kakinada, specializing in networking and security. He has more than 16 years of research and teaching experience. In past, Dr. Babu was awarded with Best Teacher Award twice at Yale University, Vadeshwaram. Dr. Babu has held various administrative positions at KL University, Vijayawada. He works in the area of blockchain technology, Internet of Things, IoT security, wireless networks, and wireless ad hoc network security. Some of his areas are DNA cryptography, managed IoT security using blockchain, security attacks, and defense measures. He has credit of more than 65 international publications, including journals and conferences, 15 book chapters, and more than 80 invited talks across various states. I'm glad to convey that Dr. Babu received CSI Academic Award at International Conference held at Science City, Kolkata in January 2018. Such a versatile personality is going to guide us today. I welcome you, sir, and request you to start the session on Introduction to IoT. Thank you. Over to you, sir.
Thank you very much, madam. I'm audible?
Yes, sir.
Yeah. Very good morning to all of you. It's my privilege to be here, to be a chief guest, as well as my session will start on IoT on the second phase. First of all, let me thank the management, the principal, the coordinators, and the head of the department for inviting me as a chief guest and to give the sessions, 3 sessions on IoT. See, this is the second phase. I heard from this is the second phase of IoT. I think the people already benefited in the first phase, and you received a good feedback on IoT. Right, it's a good thing that the institute is working towards the faculty development programs and towards the latest technology. Now, this is an era where you are coming across very close to the industry. If you see the our beloved vice principal sir has already explained, along with the principal sir, given briefly on IoT. It's very good to have because the technology which you are going to learn, like in the form of Industry 5.0 or 5.0 or 4.0, there are so many technologies which are the part of the industry oriented. We are not studying as an academic oriented only. If you take the IoT, Internet of Things, big data analytics, or virtual reality, augmented reality, or we can go for big data analysis, machine learning, artificial intelligence, fog computing, edge computing. So these are all the technologies where the industry took up, and they are working on to solve the day-to-day problems. It's good to have such type of FDP programs, so that you can export to the technology, and you can take to the next level where the student can be benefited, and when the students are working in the industry, definitely they will gain more benefited. The only thing is now, when it comes to the in this pandemic situation, now how many people are really interested to sit continuously for 6 hours is the biggest challenge, right? Because we cannot see, there is no synchronous mode. We cannot see you and you cannot see me. That's an important thing, and you can mute yourself. So there's something like there is no transport mode of learning. It's individual, where you should have a passion to learn the technology. It doesn't mean that you cannot learn the technology without attending this course. You can, but you need to spend your man hours almost. If you want to learn one topic, you need to spend 30 to 40 hours, which is very difficult. So I think the management has taken a good decision to call the eminent persons from the international level, and from the academic level of high repute, to explore the knowledge, to share the knowledge to the participants. It's a very good to have. I think one more phase is there, which is very good to have. I personally congratulate the coordinators, the management, for encouraging such type of FDPs to the faculty members. Even I welcome all the participants for this FDP program, in spite of your busy schedule in your academy. It's very good to have. Let's have fruitful sessions, so that at the end of the day, the faculty should get benefited of it. Once again, I thank for giving me this opportunity to be a chief guest for this inaugural program. I congratulate all the coordinators for conducting such a wonderful FDP program. Thank you, Vandana. Over to you, madam.
Thank you, sir. With the permission of today's chief guest, I declare that the inauguration session is over. Now we'll start with the first session on IoT, that is Introduction to IoT. Thank you.
My screen is visible to all the participants?
Yes, sir.
Okay, very good morning to all of you. Now, before I start the first session, I think this is the second phase of this FDP program. The first session of the second phase of FDP program. Already in the first phase, how many faculty members already attended this IOT? May I know how many people already attended this FDP program in the first phase? Suresh, madam, can you unmute yourself?
Yes, sir.
Yeah, thank you. Now, I want to ask, because we have this as an interactive session rather than passive mode of learning. Passive mode of learning means, see, I can't see you. Only thing is, I can see how many number of participants are attending this program. I can see it. That's a major problem we have in this pandemic situation we are going to have. Now, the question comes to this, if you want to make this session as an interactive session, so if you try to respond a few things so that it will be more interesting session rather than only one way of representing. Right? How many people belongs to the computer science?
So actually 30% of the participants are from computer science background,
Okay,
and 70% are from electronics background.
Oh, the more number of electronic people were there here, I think.
Yes, sir.
Yeah, right, very good. Then if such is the case, now we need to be aware of, right, how can we, means we can concentrate the combination of both the people, right? Okay, let's we start quickly some of the important topics of this IoT. If you have seen from last 5 years, 5 to 10 years, there is a lot of tremendous change in the technology. Various trends were involved, and we need to be we need to cope up with those technologies. That's why these type of FDPs will help us to learn more and more and more. So my session will go like this, which you're going to see. The first part which you're going to discuss is what are the various trends and technologies in the industry 5.0 or 4.0? What are the trends that are going to come? The next one is how this internet is playing a vital role, and how it is has become the part and parcel in our daily life, and how we are habituated to use this internet. And without internet, life will be miserable nowadays. And quickly we'll try to see some of the statistics of IoT. Why we are talking about the statistics of IoT? Already the devices, the tiny devices, right? The tiny devices are already dominated the humans. If you see in 2013 itself, already the more number of devices are there than the people. Right. So how these devices are going to be connected to the internet and how we are going to organize it, that's important. Then quickly we'll try to see some of the concepts of the IoT. If you see the different people, they will give different types of concepts, because there is no standard definition on IoT. If I give, I will take a definition from ITU, International Telecommunication Union. Or someone will take Intel definition, someone will take the Cisco definition, someone will take ESTA definition. Maybe these definitions may be different, but technically they are same. Right? They are going to give the common meaning. So therefore, we need to know what are the concepts of IoT. And a very, very, very important thing, if you want to build or if you want to deploy any IoT, any IoT device, or if you want to set up anything, you require a proper architecture, because it's not that much easy to have on that. So if, for example, I'll take one Arduino kit and take some sensors, I'll connect to that Arduino kit, and then through a Wi-Fi model, I'm going to send the data. Now, suppose, for example, we are going to have some 100 Arduino kits. Now, how to operate those heterogeneity? Because 100 Arduino kits of same nature, we call them as a homogeneous. Now, if you take Arduino kit, the Raspberry Pi kit, or some other hardware devices which you want to connect it. Now, what about data which is being generated? They are same or they are different? That's the biggest challenge we have. So, therefore, we need to handle that. We need to handle a lot of challenges in IoT if you want to deploy these things. Therefore, we need to have a proper architecture that I'm going to emphasize in today's session, along with the basic concepts. And finally, in the first half, we'll try to conclude in the first session the challenges of IoT. Right? If any one of the faculty have any doubt, please you can ask there itself. Okay, it's my pleasure. Now we'll try to see some of the trends and the technologies which you're going to have, which you're going to see. We are going to have now. Very soon, already it's already there. Some of the companies already started working on providing the 5G, and they have been already integrated in the mobile devices. Now, 5G is a distributed system or is a centralized system? Is a distributed network or centralized network? 5G. Anyone? Now, if you see the more number of the base stations, which are going, yeah, very good, absolutely. There are more number of the base stations which are going to have, right? It's something like a distributed network, and it's a faster internet and a faster future internet we can have. So very soon we are going to enjoy the fruits of this 5G network. Already a lot of work is going on to establish the infrastructure for the 5G network. The next one is a very important one, is the cyber security, the machine learning security, which you can have it, and the AI. Unfortunately, actually, this is not a new technology. From last 20 years, academia people, they did a lot of research work on this AI. Now, the industry took up these AI principles and they want to implement in the various technologies. That's why we are talking about the machine learning, the deep learning concepts, because we need to train the data, but we need to train the algorithm to take the appropriate decision making. Now, along with that, the cyber security is an individual component. If you take any technology which we are talking about, the cyber security is a very, very, very important in order to make that technology a successful one. So, therefore, there is a lot of relationships were there with cyber security and AI. And then people were talking about the big data analytics and big data analysis. We are going to see now the very important part which you're going to see is big data. Now, so when we talk about the IoT, now IoT is going to generate huge volume of data. Now, how to convert that big data into a smart data? Right? How to convert that big data into a smarter data? This is a very important thing. Now, see, whatever the data which you are going to get, it can be a static data we are talking about. Now that's static data. Now when we talk about IoT, IoT is going to get real-time data. Now this real-time data need to be converted into a smart data. Right. Now how to visualize this big data concepts, especially as a part of the Industry 4.0. The next one is digital currencies, which we call them as a cryptocurrency. We have nothing to do with the cryptocurrencies, but the underlying technology of this Bitcoin is a blockchain technology, where it is going to provide, it has been proved because it is going to provide transparency, enhanced security, or it is going to provide without any trusted authority with a decentralization. So therefore, digital currency is another important technology that is going to use as a part of the Industry 5.0 or 4.0. Then, if you see, the next important one is assisted transportation system or vehicle-to-vehicle communication, which you are talking about. See, the vehicle-to-vehicle communication is going to happen. Right, a lot of research work is going to happen in the automobile sector to integrate the various sensors, various automatic sensors will be there in the vehicle-to-vehicle communication, which you're going to see as a vehicle ad hoc network or vehicle-to-infrastructure communication, which is happening. The next one is we are talking about the industrial cyber physical system or industrial IoT. Right, which all these technologies, the industrial IoT requires 5G, it requires AI principles, it requires cybersecurity features, it requires big data, it requires blockchain technology. It is a part of the system transportation system which you're going to have. And then we are going to talk about, because the IoT devices, which you're going to talk about, intelligent devices, right? Why they are intelligent in the sense? Because, see, for example, now if you see, you have a small sensor device, and this sensor device is something like, we call them as some. Any doubt? Any doubts? Okay. Now, what we are talking about, we are going to talk about a small sensor data, which you are going to have it. A small sensor data. Now, this sensor data will be connected to some sink, or we call them as a broader router, right? Lower broader router, which you're going to call them as low power. Now, we are assuming that because these devices, the sensor devices, these are very low power devices. Their battery is limited, their memory is limited, their bandwidth is limited. So what we are going to see, always they will be in sleeping state, right, to save their energy. Now what we are going to do, someone should be there to wake up. Someone should be there to wake up, and whenever the data is ready for this type of data, whenever the data is ready, and this automatically this device should be wake up and it should send the data to the low power devices, and through this it is going to connect it to the internet world, and it is going to happen. Now we call this as an intelligent device, a smart device. Why it is smart? Because whenever the data is ready, it will wake up and it will send the data. Whenever the request is come from the end user, and it will wake up and it is going to send the data. And accordingly, we are going, the end user is going to take the appropriate decision. So therefore, we are going to call them as a, now the industry 4.0 is all about intelligence, right? Is all about intelligence. Industry 3.0 is all about the information age or automation age, we can call them as. But the 4.0 is all about the intelligence. We are talking about everything is on appropriate decision making, right? The next one, we are talking about the very interesting one called the edge computing. Now, this is a little bit interesting. In 2013, major companies, Intel, they started working, and the Cisco, they started working to introduce this mobile edge computing concepts, right? Why can't we? Because everything that the sensor devices is purely depending upon the cloud, right? We are relying on everything on the cloud. Now, there are certain problems were there to whenever the data is sending from here to cloud. So how to handle the data? There may be some bandwidth issues is there. There may be some latency issues will be there. So how to handle such type of problems? So they started working on mobile edge computing or fog computing concepts. The next, we are enjoying the fruits of cloud computing. already from last 15 years. We are enjoying the fruits of cloud computing or cloudification, right? The people who are working on distributed cloud, which you could call them as, right? One of the best example of this distributed cloud is fog computing. Then, right, as I already told you, the AI principles which are going to have it, and then we have a machine learning, we have a deep learning principles which are going to have it. Now, how can we apply these? There are two technologies, or there are two technologies which are very important. One is cyber security, the other one is the machine learning, where we need to apply for each and every technology. For each, and it can be applied, right? Which are written. Then the fog computing, if you see, this is This is the fog computing which you're going to have it. These are the fog nodes where they are very close to the edge nodes, which you can call them as. And this is a cloud node. All these fog nodes will be connected to these edge nodes which you're going to have it. These are all part of these. These nodes are all part of the IoT devices which you're going to have. Right. See, now this is a digital stock base, as rightly said by our beloved Vice Principal Sir and the Principal Sir in the inaugural program. Right. Now, so there is a biggest challenge is there, especially for the teaching community, especially from the computer science people, electronics people. Every 3 to 4 years, they need to get updated, especially. Right. Otherwise, they will be outdated. That's a major problem we have, especially in the teaching field. Right. Every 3 to 4 years, even now, we are going to see every 6 months new technologies coming, and we need to adapt it to the new technology. Right. That's the biggest challenge we have, especially now. When we talk about the Industry 4.0, there are some digital shockwaves which is reflected to each and every sector. Right, each and every sector. If you see in the agriculture field, even the farmer need to update it, because the farmer, if the farmer is using the mobile, you need to get updated how to use this mobile technology, right, for solving the problems, the personal problems which you will have. Now, even the electrical, the electronic people. So what we are going to see, the electrical people need to be updated, like, because you see smart grid concepts, smart electrical systems which are going to use it, electrical vehicles which are using nowadays. The electrical people need to be updated how to use this IoT concepts in electrical. Now, if you see structural engineering from civil sector, right, how to use structural monitoring, how to know the wealth and health of the structures. If you see mechanical people, how to use the cyber physical systems, we are going to use like mechanical people. If you take biotechnology, you take any sector, they need to be updated nowadays, because they cannot rely on the old technologies. They need to get updated. If they were, otherwise they will be outdated. So that's why we call them as the digital shockwaves we have. We have evolving challenges. We have a lot of disruptive technologies. The way of working style has been changed. Now, if you see, no one has thought from last 1.5 years, actually, now we are doing everything through online. Even we never dreamed that this much fast we are adapting to the online classes. The students were listening online classes. The faculty were listening online classes, sitting at your own place, listening. Like a lot of online tools were available, right? So if you see, even Google Meet, no one has started to use this Google Meet before 2019. Now in 2019, maybe in 2020, from February, people were started using more effectively this Google Meet, right? See, that's why we are habituating some online tools for listening the online classes and everything through online. So the working style has been changed drastically in this pandemic situation. New business models were introduced, right? Accordingly, we are going to use it. So now these are the new solutions we have. I request the participants, please see all these 4 digital shockwaves which you're going to have it. Now, if you observe here, the business models which you will have it, there are so many new business models have been introduced here. If you observe here carefully, the business models, the intelligent network enterprises were introduced, the digitalization of energy were there, and the blockchain technology were introduced, and the blended business models have been proposed as a new business models. Now, if you see, we have a developer app, developer ops were there for large organizations, augmented interactive reality, wearable devices, a lot of wearable devices we are using, and interactive multimedia, dynamic media we are using now. Now, these are some of the challenges we need to solve. We need to apply a lot of deep learning for appropriate decision making, right? So we need to use the IT of life has been changed drastically. We need to use the security. The data which you are getting, because we are going to connect the 4G data, 5G data, the data will be generated much faster rate. How to handle this data, fast data, and how to have the identity and the privacy. Now, see, I think anyone heard about this one? See, because what is the major problem with cryptocurrency? Why the government is not encouraging? Because the major problem which you win on the if the user A is there and user B is there. Now, if you want to send some coin, Bitcoin, which you can call them as, we don't know, because though we are sending in a network, we don't know the identity of this fellow. We don't know the identity of this fellow. Now, how can I come to government will come to know that whenever he is sending a Bitcoin to the other person, but we can verify whether this fellow has sent the valid Bitcoin or not. But we don't know from where it is coming and to whom it is going, because we are sending with the public addresses. So the biggest challenge we are going to have it identity and the privacy issues need to be ensured. So some of the disruptive technologies, we call them as additive manufacturing, cloud containerations, memory computing, the IoT and the future networks which are going to have it, cloud continuum and quantum safe cryptography are some of the future disruptive technologies which are going to come across. So this is the industry 4.0, which we can call them as. If you see the industrial revolution, we are talking about the computers and the internet. This era is from up to 2015. We have from information age as well as the automation age. From 2015 onwards, we are going to use a lot of new technologies like IoT. We are talking about big data. We are talking about AI, which is all about the intelligent systems, which are talking about the intelligent systems. Okay. Now, the next question comes to you: how these intelligent systems? Now, my question to the participants: Bluetooth, whatever we talk about, whether it is infrastructured or infrastructureless network. Bluetooth is infrastructured or infrastructureless network. I'm audible, no?
Yes, sir. Yes.
Anyone knows about that? Bluetooth is infrastructured or infrastructureless network. It requires any base stations in order to communicate through the Bluetooth. So please be a little bit active so that it will be more interactive rather than passive mode of learning. Yeah, no problem. What we are going to see, the Bluetooth is the infrastructureless network, because if you see why it is infrastructure, it doesn't require any infrastructure like base station. Right? What we can use it is the infrastructure. Even wherever we go, we can quickly form a network. So Bluetooth, along with the smart app, which is going to relate into the industry 4.0. And there's so many things were there in the industry 4.0, because we use Bluetooth low energy, right, which is also called as Bluetooth smart, right, which is a Bluetooth 4.0, which is going to have it. All the mobiles now are Bluetooth smart. Now, if you see, we can integrate these tiny devices, tiny small sensors or Bluetooth enabled devices. It can be from ranging from small, large things which have been there to the medium size things, or to the small or the tiny things we can have. A single sensor or the component typically will have a large installation. So we can have from a large things to the small tiny things, which are the part of the which are going to be connected to the internet, right? Which are all comes under the industry 4.0. Now, if you see the waves of information technology, which is happening from last 40 years, there is a lot of change, tremendous change in this information technology. If you see from 1950s, thanks to the ELSI, thanks to the very large integrated circuits, because they are bringing the computational power very fast, which you are going to have it. So we are going to have, we started from 60s with mainframe computers, mini computers with us in 70s. Microprocessors we have in 70s, distributed computing we have in 80s, which you are having. The next we are talking about the very important is a multiple technologies integration. The future is all about we require a multiple technologies integration. We are not, if we are good in one technology, you are not good in. So you should be good in multiple technologies. So because now we require multiple technologies integration need to be done. So for that, we are talking about what the industrial Internet of Things. The future is all about, we are talking about industrial Internet of Things. It requires multiple technologies integration. So the future innovation is all about what we call them as, an IoT, we call them as a cloud, big data, AI will be the future innovation. Why? Why? Right? So there are few things to be known here, because the data explosion, if you see in 2020, last year itself, 44 zettabytes of the data is already created, which is a very huge volume of data. And this data is a real data. This data is a real data which can be used for making appropriate decision making. And if you see, the people are behind the devices, right? More number of devices were shipped already in 2017. So already in 2020, 50 billion devices are already connected. Now, if you see the 50 billion devices, how to handle it, that 50 billion devices? Because they're all connected to the internet now. The biggest problem is how to handle it, how to identify those devices. So therefore, the future is all about, we need to be aware of the IoT, we need to be aware of cloud computing, we need to be aware of big data, we need to be aware of AI, and the future is innovation is all about learning all these techniques. Okay, right. So we came such a long way when we are going to see now. If you see here, usually the mainframes are one per enterprise, according to that computer. Then a mini computer will be one per company, which you're going to have. Then we're going to have a workstation, one per engineer, right? And then a personal computer, one for family. Can you see what is in 1990s? You get it? Can anyone tell me? After personal computer. Hello? What
Yes, sir,
will be
you are
there in
audible.
90s? So in 90s, we have a laptop, one for professional, which you can have. And in we are going to have, in 2000, we started using the smartphones, one per person, which is not necessarily true nowadays. And then the future, why we are talking about IoT is because of this, because smart sensors. Usually smart sensors per person we can have from 100 to 1000. Due to this, actually, if you take a mobile, may have 100 sensors, a smart mobile. So usually we can have from 100 to 1000 per person. Definitely, it can have more number of smart sensors will be integrated in a particular device, right? So due to this, actually, the evolution of the IoT. Now, if you observe that, which you're going to have it now, if you observe from 2013 to 2003 to 2020, which you're going to have it, already the more devices connected than the people. Here itself you can see. If you see what number of devices in 2020 is 50 billion devices, whereas the population, world population itself is 7.6 billion we have. So therefore, actually more number of devices are already connected to the internet. So we can call them as a IOP is replaced with IoT. What is IOP? Anyone? Anyone? What is IOP?
Internet of people.
Yeah, very good. Now, internet were used by the people, right? They are used by the people. Now, the things were used. The things you are going to be connected, and they are going to provide a machine to machine communication, which would IOP was replaced with things, right? Which would very good. So we can say we are going to see from traditional IT world to IoT world. This IoT world is something like we can call them as a IT plus OT. IT plus OT. IT is the traditional IT sector where we have a lot of web pages, web servers. We have a lot of traditional IT. We have data centers. We can have it. But OT is an operational technology where it will generate a huge volume of data, and whether your IT is able to handle this OT data, that's the biggest challenge we have. So the biggest, now we are going to see, right, one of the wireless global traffic, right, global traffic with wireless technology is generated with non-PC devices. So therefore we are introducing the IoT from 2015 itself. Okay. Now we'll try to see the technical aspects of the Internet of Things concepts. As already told you in the beginning, there is no one universal definition we have in IoT. Now, why? Then because the different companies, they use different definitions, right? Understanding that if you understand the definition, though the definitions may be different, but the concept is same. Now, we'll try to see, to summarize, rather than going to the different definitions. Now, before I go to the definition, I want to ask each and every participant where we can use this IoT. Where we can use this IoT? Anyone? Everyone should answer now. Where we can use IoT? In which sector? Healthcare, very good. Healthcare, yeah. Very good. Healthcare only. Only in healthcare sector? Agriculture, very good. Industrial application. Only few members are responding. Other people are not responding.
Medical applications.
Medical applications, very good, sir. Already medical healthcare they have used. Inventory, they use. The smart city, they use. Right? Defense sector, very good. See, if I ask now, 33 participants were there here. If I ask 33 participants will use 33 into even multiples of 10 also, we can say. Now, in almost all the sectors, yes, sir has given, Mohammed sir has given almost all the sectors that IoT can be used. Now, if such is the case, now in which sector we can use IoT is, IoT can be used everywhere. Now, if you see here, why I'm telling all these things, because it can be used in each and every sector, in the service sector, in application groups, in location-based, in device-based, right, in buildings, energy, consumer and home, healthcare and life, industrial, transportation, retail, security and public safety, network. These are all different types of sectors which we can use it. If you see application groups, right. So to conclude, we can say it can be used everywhere. Right? IoT is everywhere. So instead of call the IoT, we can also call it as what? IOET. IoT. In the Internet of Everything. Internet of Everything, which we can call them as. So different of, if you use right, medical devices, we call them as a medical things. Internet of medical things, which we can have it. Right? The devices which you are going to use, the sensors which you are going to use to be connected to the internet. Right? So if it is such an important application, if it is such an important technology, because it is going to apply for various applications of various services, it is going to provide it to the mankind, and it is going to bring very close to the nature. Now, the definition itself is a very complex one. So, therefore, to give a universal standard definition is very difficult for such an application. So, rather than going into the definition, we'll try to see this IoT is a 3-keyword letter we can have, which is a very important concept. The first one is the internet, which is heart of IoT. The second one is the thing, which you are going to talk about, the small tiny things, which can have ranging from small tiny things to large giant machines. And these things will generate the data, which is called as a real-time data, which you're going to get the data. Now, the very important one, being a technical person, I think even I heard from Madam that most of the faculty, 70% faculty are from EC and 30% from computer science. I think most of the people you have come across what is this internet is all about. Now, see, if you see that the internet is something like a network, someone will call them as a network of network, or someone will call them as a wide area network, someone will call them as a TCP/IP protocol suite, where it will be communicated. Now, if you see here the line which you're going to have it, we can have this all the Bluetooth, the internet enabled one. We have a LTC advanced, EC people can be available, cellular network, 4G, right, 3G we can have, or 2G we can have, weightless WiMAX we can have a dash, we can have a Wi-Fi, we have a Bluetooth enabled, ultra wideband, Z-Wave, Zigbee, 6-low power, IBB 6-low power personal area network, near field communication, and RFID tags which can have it, and the power line Ethernet printed communication. These are all part of the internet which are going to connect it to the various network technologies we can have it, like in the form of wide area network, metropolitan area network, and a personal. But IoT specifically is a personal area network. When we talk about IoT, it's a personal area network. Everything is about personal area network which you have to use. So the first one, which we're going to call them as that IoT connect all the things, which is all internet enabled. Then we call them as what? Internet of things. If you see, this is the one thing, this is another thing, this is another thing, this is another thing. All are going to be connected to the internet. All are connected to the internet, which are going to have. Right. So therefore, all the things will be connected to the internet. Therefore, we call them as what? Internet of things. That we already know. The second one is a very important one. Is the things. Now, why we call these things? This, if you think this is a small sensor enabled, we can have it. Right. Now, these things have some important constants. Why? These things are what? High constraint nodes. We can call them as what? We can call them as what? High constraint nodes. We can. These are the high constraint nodes we can have. Why these are all high constraint nodes in the sense? There are some important constants. One is the physical size. The physical size of devices are very small and tiny, right? Which we will do. The second one is the processing. The CPU processing power is very limited in these devices. So we have a limited processing power. The third one is the memory. The memory is only few tens of kilobytes. As per the norms, they are very limited. Then bandwidth. The maximum bandwidth in these devices we have 250 kilobytes per second, which is very low norm rates, very low data rates as per the norm. Because the major problem, not only, of course, these are all some of the physical characteristics you can have. Physical size, CPU power is limited, memory is limited, bandwidth. But the major problem is the power consumption. Right? The power consumption. Which these devices are low power devices. Now, very low power devices, because they will not be always active. Like if you say a small kid of 1 year old or 6 months old, their energy levels will be very limited. Always what they will do, they will be in sleeping mode. Whenever they will get hungry, they will take the food, again they will enter the sleeping mode. So the power consumptions are especially is very critical in these devices. They are battery enabled, battery powered. So energy efficiency is a paramount in these type of uses, which the IoT devices need to handle very effectively. Right. That's the second point which you. Now, if you see why we call them as what? If you take any electronic device, which we call them as a smart device, it should have some important properties. What is that? Autonomously. If you say the smart refrigerator, it is working autonomously and it should have some interactive. Whenever a mobile node enters into the proximity of the refrigerator, now this mobile node, this refrigerator should send a mention message after identifying the location of that mobile, and then the message should be like that. It should be send a message to the mobile device like don't forget to buy a milk. And whenever that message been received through app, the user can see that message that the refrigerator is sending a message to the mobile devices that don't forget to buy milk. So what is happening here? We are going to see it is performing interactively and autonomous, which you're going to have. So therefore, we call them as a smart device, is an electronic device that can be operated to some extent interactively as well as autonomous. Because of this, people were talking about smart things like they use a smart grid, smart city, smart home. All these things will come into the picture. The third one is a very, very, very important one, is the data. Now, data is the value nowadays. Data is the money, right? Data is everything we have. If you have a bad data, then you are crorepati, we can call it. So data is a value nowadays. So why is this? Because these things are generating a real-time data. Now, these real-time data will be very, very, very useful for performing the decision making. So if you see, for example, we have electricity. Now, I want to know how much it is consuming at each level. Now, how much light is consuming, right? How much of the fridge is consuming in a month? How much energy is consuming in the computer, TV, we can have in kitchen hour. So what we can say, that once the data is available with us, definitely we can take the appropriate decision making. Right? Now, there is a lot of differences there with the IT data and the OT data. IT data is the static data, which is already generated in the past. Now, but OT data is a very important data, right? Which is going to be generated in real time, which you're going to have it. So that's a main important part which you're going to have it. So the Internet of Things is heading toward the fully connected world. So based upon this, all these three keywords, we can say what is IoT is the Internet of Things is nothing but intelligent connectivity of the physical devices, right? That is going to have a massive gain in terms of efficiency, the business growth, as well as the quality of life we can have. So there's a lot of changes that the Internet is going to bring to the market. Okay. The participants, you have any doubt before I go to the important topic called IoT? Right, it depends, madam. What is the maximum life we can have? Because what is the energy? What is the energy it can have? Suppose it can, if you take it battery enabled with nylon battery, which you can have it, we can have it 1 hour, 2 hours. We can have it, or if the battery is good enough, we can have 8 hours. So depending upon what type of device or whatever battery you are using, and what type of device and what type of application you are going to use it, how much it is going to consume. It depends upon different type of batteries you are using and which of different type of application, what type of device you have. Depending upon that, we can have the maximum life of an IoT.
Thank you, sir.
Any other doubts from the participants? Okay, right. Now, see, these are all the different definitions. Now, my question comes to you people. There are so many things were involved. All right, we can say that the internet is a very complex system, and things, millions of devices are going to connect to the internet. Someone should handle that. So, if you see this architecture, which you're going to have, we have physical devices. It can be some sensors and actuators. Then definitely we require some connectivity that we are going to use, like in the form of gateway. right? These are all some gateway. And then we are relying full-fledged cloud, because whatever the data, because user need not to worry once it is connected to the cloud, because even there is a mobility, the nodes in the mobility is there also, the gateways have some mobility, mobile gateway we are using also. We need not to worry, because everything, whatever the data is coming from here, automatically it is going to store at the data center server, the cloud, right? We know that because the cloud is going to provide a very good solution to the IoT. And then the application which we are going to talk about, through the applications which we are going to analyze, we are going to use big data analysis and big data processing for efficient decision making. So therefore, this is the IoT architecture where we can have in the form of devices, gateways, as well as the IoT platforms. Right now, we are unfortunately, because if you see, there is a different IoT architecture we have. Right, like I told you, IoT-A has proposed its own architecture, ESTI has proposed its own architecture, ITU has proposed its own architecture, Intel has proposed its own architecture, Qualcomm has proposed its own architecture. Now, this is a one reference model. Like in computer network, we have a reference model where we can apply in reality, that we call them as an IoT World Reference Model, or IWF. IWF reference model can have. Now, this reference model will give a lot of clarity wherever we want to use it. Now, if you see, this is a 7-layer model. This is a 7-level model. We can call, rather than calling as a layers, we can call them as a different levels, because each level again it consists of some sub-layers which we can have. So we can have the first level is the physical devices and controllers, where we can use a lot of Arduino or Raspberry Pi at these levels. And then the first level. The second level is the connectivity level, which we can use a lot of Zigbee network. We can use a lot of Bluetooth enabled network. So connectivity will be done. And then the third one is a very important one, is the fog computing or edge computing. The fog computing and the edge computing, which we're going to talk about, which we are going to use it here, how to handle, because the data which is coming from these sensor devices, if you are storing it with cloud, there may be some bandwidth issues will be there, network issues will be there, latency problem will comes into the picture. So how to introduce this fog computing, which are working very close to the edge level. And then we are going to call them as a data accumulation, which we can call them as what? A cloud computing. Which we are going to call them as what? A cloud computing. Right? Data accumulation, which you can have. Then we are going to make a data ready. Right? And data ready, because the data is coming from the different sources and we are going to store into the cloud, and we need to keep data ready to the various application users. For that, we use data abstraction for data aggregation as well as the access. And then applications which you're going to use it here for reporting, analysis, and control, we use a lot of applications. And finally, people will use these applications for collaborating. So this is a 7-layer model, a 7-level model, which you're going to use in the IoT. There is a left side is there. This is the OT data, which is a query based, which is event based. That the IoT is going to work based upon the event trigger, right? And then there is the IT, which is going to have it from the cloud side. There is the IT sector, traditional IT sector, which is a query based, right? So now, if you see the other side, the data which is IoT, OT is a real-time data, which you are going to convert it into non-real-time data. How? Because the data in motion, we are going to keep at data rest. The data is flowing here, and we are going to store somewhere at data rest. So this is a very important model where we can use as the IoT reference model we can have. Now, if you see, this is the IoT in the process layer, which we're going to see. If you see from my first slide, which will cover. So the other name for the IoT is called as a technology integrator. Right? It is going to integrate multiple technologies. IoT is not a single technology. IoT is a multiple technology, because if you are an easy guy, you are going to work on physical layer as well as connectivity layer. If you are a computer science guy, you are going to work on fog computing, edge computing, networking, as well as on the big data analysis. right? So therefore, we require multiple technologies to be integrated in IoT. If we start here, we have various things, we have various devices, we have various sensors, which are part of the edge devices. And we are going to use a 5G network or 4G network. We'll have a both, where it have a both the things, what is called as local area connectivity as well as wide area connectivity. We can have like Zigbee network, we can use it, or 6LoWPAN network, we can use it, or Bluetooth network, we can use it, or a large wireless sensor network, we can use it in order to connect both local area connectivity with the LoRaWAN. This is LoRaWAN and the Sigfox network. And then you see there is an interesting one called in the level is there called edge computing or fog computing. We'll try to see in the subsequent slides how we can use that edge computing and what is the role of the edge computing in IoT. We have a data element analysis as well as the data transformation, and then this is a cloud infrastructure which you will have. So therefore we can say the process layer in IoT is a very important. We can. Right. Now, the first one is the physical devices and the controllers, which you can have it. We can, as I already told you, the devices can range from small, tiny devices to the chain divisions. We can have sensors, we can have devices, we have machines, we have intelligent devices of all types. Now, I want to know some devices which are data carrying devices. Now, can you tell what is a device which we are using very frequently nowadays as data carrying device? Anyone? Data carrying device, data capturing device. There are two devices which are there along with the sensors. Data carrying devices and data capturing devices. Madhura madam, smartphone is capturing or carrying? Data is going to it will be carried. No, I'm talking about devices. I'm talking about these devices. Sensors is capturing device. Very good. Sensors has comes under capturing. Now carrying. Now what about RFID? RFID tags. Yeah. Sensor-based RFID tags will be both capturing as well as carrying devices. Wherever there is a need, it will capture, and wherever there is a need, yes, yeah, definitely. Even USB cable is going to, the USB cable is going to transfer the data, but we are talking about capturing and carrying that the data to that. RFID tags is going to perform certain information which you are going to have. So we have a lot of sensors we can have a lot of devices we can have, and we have machines, intelligent edge nodes of all categories which are comes under this category, the physical devices as well as the device controllers. What is the capability of this one? We need to perform the analog digital conversion as required, and the main purpose of these is going to generate the real-time data. And then we are going to use, because the query is going to come from the upper layer, and it is going to be, we can convert into event based, and we can control over the network sitting at different places in the remote area also. The second one is a very important one. It's a very important in the IoT is the connectivity, right? Which you're going to have. The main functionality of this connectivity, like in the form, the best example is your internet, which uses the connection, the communicating with all the level 1 devices, level 1 physical devices we can have. It's going to communicate with the level 1 devices. We'll try to see in the subsequent slides how it is going to communicate. Even if it is possible, we'll try to do some hands-on, maybe tomorrow or in today afternoon session also, if people are really interested to do on hands-on and IoT. Right, so communicating with or between the level 1 devices we can have, and then see all the IoT devices are unreliable network or reliable network. IoT networks are unreliable or reliable? Unreliable. Very good. So very good. So because why it is unreliable network in the sense we don't know we don't know when the node will be there and when the node will be moved, when the node will be joining. Suppose, for example, if this is a transmission range we can have, a node can be entered anytime and a node can leave anytime. And there may be some path disconnectivity, a packet loss can be happen very frequently. So this is definitely, it's an unreliable network, we can call this, right? An unreliable network. Now, how to ensure reliable communication over unreliable network? This is unreliable network because we have unreliable people. Unreliable people. How to ensure? Suppose, for example, I don't mind, I'm giving an example of that. It won't take, otherwise, it don't take to the person. Assume that there are few faculty are there or few students were there. They are unreliable. They are not going to answer. They are not going to give anything. All right, and what is going to happen is to encourage, there are few people who will be there who are going to give the answers, and then they want to conduct this FDP successfully. How they want to conduct? Because we want to provide a reliable data transfer. What is that? For example, assume that if no one is giving the answer, then what is that? Actually, now to give some reliable solution, that the coordinator, they are going to give the answers, right? To make this the session very active. So now reliability to be achieved here, isn't it? On an unreliable network which can happen. This is an example for that, isn't it? So we have unreliability because we don't know when the node will be active, when the node will be in sleeping mode. So right, but still we need to provide a reliable data transfer across the networks. That's the biggest challenge we have, and the network connectivity need to provide this solution. The third one is now whether we can implement the various legacy protocols or we want to implement the new protocols. Like a lot of research work is going on how to implement this new protocols we can have. Fourth one is a lot of switching mechanism and a lot of routing mechanism need to be applied, right, which is required. And a lot of translation between the protocols. Now I want to ask a question. Gateway is what? Gateway is what we can call them as? What is the purpose of gateway? Mobile gateway, or we can have internet gateway, or some gateway is required. No, what is the purpose of that? Gateway. A router is different, gateway is different. A router is a 3-layer device, gateway is a 5-layer device. Okay, very good. Two heterogeneous networks you want to connect. So what? Now, what is the advantage of that? Multi-rate processing. Now, see, for example, okay, very good answers from the participant side. I think I feel very happy if people are responding more effectively in this in online. Now, if you see here, we can have it. Now, let me assume something here. Now, there is a EC faculty will be there. These are the EC faculty we have, and these are the CSE faculty we have. Now, see, there actually the CSE people will be good in software. The EC people will be good in hardware. Right now, the EC people are very good in hardware and as well as communication, whereas the software people are very good. Now, what is that we require? If I want to provide an efficient communication, these people, the EC people doesn't know about the software, and then the CSE people, the CSE people doesn't know about the hardware because they know only a little bit. They are not concentrated on physically. Now, someone should be there who work like a gateway, who can provide the translation, right? Now, whatever the hardware it is required, right? Whatever the software it is required, it is going to communicate it and it is going to process it. And software is required, it is going to process it and it is going to communicate. So that's the one way it means translation between the protocol translation will be done by the in technically we can call them as. Assume that EC people will understand only IPv4. Right, and CSE people will understand only IPv6. Right now, what is that? They don't know what is this IPv4. EC people doesn't know what is this IPv6 protocol. Now, what is that? Some protocol should be there to convert, to translate from IPv4 packet to IPv6 packet, and from IPv6 packet to IPv4 packet. So that can be done by the gateway. the protocol translation can be done, right? That's another one we can have. Next one is the security at the network level. We can do it very easily at this level. And then if you are saying that, I think some of the point which you're going to have it, self-learning and network analytics means we need to apply some machine learning, or we need to apply some deep learning principles to learn the to learn the networks so that it can make the appropriate decision making at the network level. These are the functions of the network level. The next one is the edge computing level. Before I go to this one, the participants, do you have any doubts here up to this second level?
No, sir. Please continue.
Yes, thank you. Now, the third one is a little bit interesting, is the edge computing level. Sorry. The edge computing level or fog computing level, which is a very new one. We already think that people have come across mobile edge computing, which can call us. Now, what is the purpose of this edge computing level, especially how it will play an important role in the IoT? Now, if you see here, what is the major problem we have, especially in the IoT, is the devices, the sensor devices will generate the data much faster than IT. IT can handle it. Right? Whether your cloud is able, now this is a cloud where we can have it, it's not capable of performing the real-time data analysis and feedback. The data which is coming much faster rate, whether this fellow is going to handle it.
I hope you understood what is my query.
Priyanka madam, can you unmute yourself?
So let's see, think about that. Okay. I hope everything is
Karzai, madam. Priyanka, madam.
Hey ma'am, unmute yourself, ma'am. Unmute yourself.
Mute करा, madam.
This is a problem with online. Okay, sorry.
Sorry for interruption, sir. Please
It's all right.
continue.
Yeah. Right. So therefore, the device will generate the data much faster than IT, and the cloud is unable to handle that real-time data which is coming from the devices. That's a much a problem. So massive amount of data which has been generated from the various devices, the cloud is unable to handle that real-time data. Right. That's the biggest problem we have. So if you see, if we observe that, because the 90% of the world data was generated in last 2 years, which can be something like web-based or IoT data. Right now, if you see here, the data transfer, again, the cost of the data transfer is getting increased. You assume that your internet charges are increasingly more number of data being used. So, and the physical storage the shortage of the physical storage is happening in the cloud because the OT data which has been generated, huge data which has been generated from that. You can see Google receives almost 2 billion such queries, and then user mails, and then YouTubes, and then can have blogs, the consumer spends, and then new websites were created. Facebook shares almost. So huge work. This is IT data we are talking about. The OT data, right? The IT plus OT data will give a large, huge amount of data whether the cloud is able to handle it or not. So, for example, you see the issue with the traditional IT sector, if you take an airplane, which will generate the multiple terabytes of the data per hour. Now, storing all these multiple terabyte of the data permanently in the cloud is the biggest problem we have, and sending to the IoT application is the biggest challenge we have. Now, how to solve this problem? We can is the biggest challenge. So, therefore, the major problem or the major challenge in the cloud computing is nothing but what too much of data which is going to happen, and then latency is too high, delay is very high. Suppose, for example, now when I'm giving the data, for example, I'm going to get much faster. Suppose I'm asking a question, the delay is very late, when the response is very late. In such cases, we can say I need to wait for 1 or 2 minutes to get response. So latency, because of some network problem, will be there, some delay will be there. Now, how to handle this latency problem? The transportation cost is too high, because we need to pay a lot of amount for the transportation cost. And then, because we are working on the unreliable network, how to keep this resiliency impractical, and how to make it practical, which you would have. The resiliency is impractical in such type of cloud network. So, to overcome these problems, how we are going to minimize the data before we upload by extracting and sending the data to the cloud. Suppose, for example, now we are placing all the soil moisture sensors or temperature sensors at different places. Now, assume that in the summer, hot summer, now a query is coming from the data center or from the user, right? Or from the user, which is coming from that. A query is going to come. I want the temperature at 11 o'clock today. Now, accordingly, what is happening? The sensors will be activated and it is going to give the common data. It is going to give a common data. And redundant data. All the sensors are placed at different places, and they're going to sense it, and they're going to give the temperature to the user. Because this data, whatever we are getting, it's a common data, right? If we are storing all the common data into the cloud, definitely it's the biggest, all the redundant data which you're going to store. How to minimize the IoT data to make it efficient decision process? So for that, therefore, definitely we can use the role of fog computing, the cloud computing, big data, AI in IoT. So therefore, we use edge computing, or edge computing is nothing but a fog computing. We use interchangeably. The cloud computing is called as a data aggregations. Big data will be used once we get the data, and then we can use AI principles to it. Now, my question to you, whether AI is used here or in anywhere, in all the process where we can use it. Yeah. Only here, or in other part we can use AI, machine learning or deep learning. Any answers from the participant side? Okay, right. Now, AI can be used everywhere. AI can be used at edge level. AI can be used at the cloud edge computing level. AI can be used at the cloud level, and AI can be used at the application level. So this is the one technology where we can use the AI at all the levels, right? Now, what is the need of the fog computing, edge computing we can have? Now, we can say the smart things, like in the form of it can be Bluetooth, the Wi-Fi, a wide millisecond response times, where the millions of devices will be. Now, we need to convert into tens and thousands of devices, where we can call them as a fog network, where it can be 3G, 4G, or LTE, or Wi-Fi we can use, like it can be a distributed intelligence, real-time response, where less number of devices. From there, we can use a core network, which will be there, where thousands of devices will be there. And from there, we can use hundreds of devices which will be connected in the form of data center. So here we are, means to convert from millions of devices to tens and thousands of devices. That's the main thing. Like, for example, if you see Arduino kit is there. Now, when we have 3 or 4 Arduino kits, or we are going to have it. Now, all these things are Wi-Fi enabled. These are all Wi-Fi enabled. Right, this is hotspot enabled or Wi-Fi enabled here. all these things are Wi-Fi enabled. Now we have a mobile device here. We have a mobile device, like mobile, which is going to work like a fog computer. It has better bandwidth, better processing power compared to the Arduino gateway. Right. So the main purpose of processing the data, now it is only one level. Whatever the data which is there, which is coming from the sensors, we are going to process it, and it is conventional. We are using from last 5 to 10 years, we are using cloud, we are using big data analysis, and then application. Now we are going for one more level, which you are going to have it. Now, how to filter the data, how to make the cleanup, and how to aggregate the data whenever it is done at the edge level. So the packet level inspection will be done here. The combination of both network level as well as data level analytics will be done at the fog level, and based upon certain threshold, right, we are going to generate it, and then event generation. Now our main motto to go for edge computing or fog computing, whatever the data it is coming from the various sensors, we need to convert into information understandable to the higher levels. For example, I'll give. Now, for example, in this pandemic situation, listening a class online for 1.5 hours is very difficult. It is very difficult. Now, what is that? Suppose, for example, if one of the participants feel that this topic is important, now what we want to do, we want to write a notes. Whether it is possible to write a notes and listening now in the online situation. In the online situation, whether it is possible to listen and write notes, live notes parallelly? No. Why it is no, madam? Because there is a problem will be there. If you listen and write, because in this pandemic situation, you people, I can't see you. I don't know whether you're writing or not. All right, just you're listening. I feel, but you're writing. So what is that? I can't see you, so that I'm going in a little bit faster. Right. So what we are going to say, what we are going to do here, rather than that, what I'm doing, rather than that, you can do one thing. You'll store all the necessary information in your brain, so that at the end of this session, at the end of the today's session, you'll write whatever it has been covered. That writing is nothing but cloud. Storing everything is nothing but fog. Storing in your brain is something like a fog, and from that fog, you're going to store only the essential information. Right, like for example, I'm asking any doubt information, you need not to write on a notes. Right, if I'm asking a question, that you need not to write in a notes. There are unnecessary information, right, which you're going to get it. So only the essential information which you're going to store in your brain, and at the end of this day, what you're going to do, you're going to write only the essential information you're going to take a notes. So what we can say here in the sense, we need to convert from data packets to uniform information understandable to the higher levels. When you see the notes, definitely you can understand even after 1 week or 10 days, after 1 year, because you have converted that information into that return into your own understandable level, right? So that's a point which we are going to say. So for that, what we are going to do, we have an IoT device. Now this data is going to give to the edge device. These are the sensors we can call them. You can call them some Raspberry Pi or Arduino kit we can have. We are going to do some processing here. Some processing will be done, and the data will be refined. And then we have some Raspberry Pi, we call them as a fog node. Some processing will be done, and refined data will be given to the cloud. So you're going to have level 1 processing, level 2 processing, level 3 processing will be done. I'll give a best example. Now, your principal of your college asked about the accurate data, right? He wants the accurate data. The principal asked some information. I want the students' information who cleared this semester with above 70%, right? Now, what is that? He's giving the instruction to the head of the department to give this information. Now, HOD is going to call on reliable faculty, right, which you're going to get. Now, I want this information. The faculty, HOD requested the faculty to give that information. Now, what that faculty will do some proper analysis, and then proper analysis, and he will give a spreadsheet. He will create a spreadsheet with all the analysis, whatever it made, but the data which is coming from the exam section. This is the exam section which you are going to get. Now, the exam section people will give whole data, but what the principal asked, he asked an adapt query. That adapt query is what I want the students list from the electronic department, EC department. I want the people who are passed with 70% grade. That you need to analyze it. Now, you need to analyze it, and then you need to give it. And once again, the HOD will process it, and if you want to eliminate certain information, he will eliminate, or if you want to include some information, he can include, and he will give the data to you. So what the principal will give, principal will have an accurate data so that he can give that information to the higher ups, or he can give that this many students passed above 70% even though in this pandemic situation. So appropriate decision making can be done if you have a different level of processing is there, right? So this IoT requires different level of processing of the data we can have. So we are going to have a communicate with the data. We are going to filter and evaluate it, and we are going to transfer into canonical format, which you're going to have it, and format to the specific target which you're going to use it, and then we are going to integrate with the IT data. So this is a device, edge node we can have, fog node we can have, and the data center we can have, which you're going to have. This is another level which we can use it. These are edge devices, fog devices, data centers, and then we are going to store into the any cloud. Okay. Do you have any doubt in this edge computing or fog computing? Anyone? Before I go to the next level.
No, sir.
Yeah, thank you. Right. Now, what we are going to do, we are going to see now once we got the filtered data, once we got the refined data, now we can use AI principles here also. The fog computing we can use it. So now once we get the data, refined data, now the main thing is the cloud is the cloud storage is refined data which you have. Now the main responsibility is now this fellow is to do how to convert the data in motion which is coming from the OT, and how to convert into data at rest. That's the first thing. The second one is converting the format from network package to relational databases. In the relational, means we are converting into relational databases. And then the main, we are going to perform some transition from a query based to event based. Means we are going to convert from event based to a query based compute. And then definitely we can see here drastically reduces the data which is coming from the fog computing. Fog computing already unnecessary data has been removed there. Redundancy data has been removed there. Right? Only whatever the essential information which is required, we are going to store into the cloud. So that what is the advantage of that? The big data processing, big data analysis can be done very effectively in the cloud, and the efficient decision making can be happen when we use 2 level of processing or 3 level of processing. Okay. Then the next one is madam, can I take, because already 12 o'clock, can I take 5 minutes, 5 to 10 minutes?
Sure, sir.
Yeah, I'll complete this one. Then in the afternoon session, I'll cover the rest of it.
Okay.
So yeah, we have a data abstraction. The next one is the data abstraction, because it's showing only the essential features which is required by the end user or application programmer. For that, we need to keep data ready to the end user. For that purpose, we use this level. So what we are going to do, we are going to create some schema. We are going to have some views of data in the manner that application wants. And say, because the data is residing at different places in the data centers. Now, how to integrate it? How to reconcile? How to integrate and to keep a common data? Right? Suppose, for example, now if you see the principal is asking to the head of the department, HOD is there. Right, all the head of the departments of 4 departments were there, and the HOD is giving different data. Now, someone should be there, right, in a mediator, Now, HOD, if you want to take some decision making, someone should be there in the middle to consolidate all this information and to give to the HOD. And even from the HOD, right, someone should be there in the middle to consolidate it, right? and to give to the principal, right? He will ask one of the HOD to consolidate it and to give it. So we need to combine the data which is coming from the multiple sources, right? And we need to simplify the application, because we cannot give to the principal, right? You take this data, or we cannot give to the head of the department, you take this data. Whether HOD risk is what to consolidate all this data. So his goal is to have a refined data set with them. So combine the data from multiple sources and simplify the application. For that, what we need to do a lot of filtering, projecting, selecting, and reformatting the data which are going to be used by the client application. For that, what we use, data can be there at different formats, will be there, different shapes will be there, schematics of the data will need to be there, access control should be there, access protocols we use, and security. So we need to process the data for fine-grained, for getting the accurate decision. So the next level is the application level, which you're going to call them. This is an application level which you're going to have it, which you're going to use it. Now the main purpose is we can control certain applications. We can have some vertical applications or mobile applications, or business intelligence can be used. So some applications is required for monitoring the data, monitoring devices. Some applications will focus on controlling the devices. Some will combine both the device and non-device data is required. Some is going to use the mobile application to handle the simple interactions. So depending upon the, even I asked that, I asked you. So different applications were there, and we can use IoT for different applications. So therefore, this architecture should be in a position to provide different types of applications. Right. So this level of the example which we are going to have to summary. We have a device, the level 1, and the next one is connectivity. Some network connectivity is required, where it can receive and send the data with this one. And then we have a edge computing. We can process the data. We can process the data, and we can get normalized data or filter the data. And then we have a data storage. We call it the cloud, where it will be residing. And then we'll process it, and we'll process the data, and we'll make the data ready to the end user. And then applications will be access those data, and finally people will use to collaborate and act. Now my question to the participants is, from the device through the network connectivity, we can send directly to the application, or directly we require edge computing, cloud computing, and data abstraction need to be done. You understood my question? My question is here now. If we have the devices, which you will have it from the devices through the network connectivity, we can directly connect it to the application. No, if it is required, yes, we can connect it. If it is required, we can connect it. Or if we can send to the edge computing, we can do it. Or we can send to the cloud computing, we can do it. Or we can process the data here. And if it is required, we can use this process, right? Or if it required, we can bypass it and we can send the information. This is a reference model which we are going to use. Now we'll try to stop here after this slide. What we can have. This is the one network. Constraint network with ZigBee, and this is a 6-LoWPAN network we can have. This is a Bluetooth Low Energy network we can have. This is a SWAP network we can have. Now all these things are going to be connected to the gateway. We call them as a ZigBee coordinator, broader router, Bluetooth hub, and edge router. And this is a fog node which we can have it. This is edge device. This is a fog devices. This is the network connectivity. We can call them as network connectivity. We can store at the edge devices. Through network connectivity, we can connect it, and then we are going to connect to the cloud infrastructure. And then we have a big data analysis if it is required. We can use it, and then we are going to use various applications. So this is a way that IoT architecture can be organized very effectively. And if you want to do any implementation, you need to follow all these things. Some customization. We'll stop here. If you have any doubts, please let me know. We'll try to start in the second half, the protocol architecture. If I want to implement anything, if I want to implement Arduino, if I want to implement in Raspberry Pi, if I want to implement in some other thing, we need to have a protocol architecture of IoT that we are going to discuss in the afternoon session. So if you have any doubts, please let me know.
Thank you, sir, for briefly explaining the application areas of IoT, the basic architecture of IoT, and all the 7 levels in it. We will continue with our today's speaker, Dr. Suresh Babu, at 1 p.m. So we'll meet after 1 hour, that is at 1 p.m. Thank you. With the permission of today's guest, I declare the first session and will continue in the second session after 1 hour. Thank you.
Okay, madam. Thank you very much.
Thank you, sir. I request all the participants to join with us at 1 p.m. Thank you.
Madam, the same link we have to use for the next session.
Sir, we'll post the link on the group. So the link will be same.
Yeah, link will be same. And
Yes,
the
sir.
attendance and feedback form?
It will be posted after every session.
In the WhatsApp group,
posted at any time in between the sessions also.
Okay, in the WhatsApp group?
Yes, sir. We will post it on the WhatsApp group. Thank you, sir.